arithmetic sequence is basically an ordered list, and you use a common difference between terms. Kind of like a constant rate of change. We would say a constant rate of change if it was a linear function. We're going to call it a common difference in this kind of sequence language because they use D in their formula. D is basically like your slope, but they call it the common difference. So common difference for a sequence is like slope for a linear function. So I'm going to star it over here. So it is like a linear function. So think all things linear. We're just not calling it a linear function because it's those, specific term 1, term 2, term 3. You can't connect it with like a line. All right, and just like in other units, there's like formulas that you have to memorize. You're gonna have these two memorized, I promise, by the end of the unit, because we're gonna use them so many times. So don't feel overwhelmed now like, how am I ever gonna memorize this? You already know y equals mx plus b, right? That's a linear function. That's basically what this is. We just write it slightly different. So we write a sub n equals to tell us that this is a sequence. We write down our starting term. Our starting term is basically like our y-intercept in a linear function. And we tell the person what the common difference is. And we want to add the difference n minus 1 times. And this is going to be the format of a lot of formulas that we do. Why do we add it n minus 1 times? Because we don't want to subtract or add something from the first term, right? So if we've got 7, 10, 13, what's the common difference between those terms? 3, right? How many times does 3 get added to the first term? It does not get added to the first term, right? So to get the second term, you would take the first term, which is 7, and you would add the common difference of 3 once, right? Because I'm on term 2. Do I want to add the common difference twice? No, I only want to add the common difference once. To get to the third term, now how many times have you added 3? Now you've added it twice, but you're on the third term, right? So the third term, if you do n minus 1, you'll add the common difference twice. So I think it'll make sense when we start doing more of these. All right, so I'm just going to skip down here to this first example before we look at recursive. You start your formula a sub n. So for the closed formula, I always start a sub n equals. Here is my sequence that I'm just doing as an example. What's the starting term for this sequence? What's the first term? So you write 4 because that's the starting term of your sequence. And what's the common difference? Is it going up or down by a constant amount? Down by 5. So you write minus 5 because that's your common difference. And then you write n minus 1 times. So that would allow you, it says use the closed formula to find a sub 15. If it was recursive, I would have to subtract 5, subtract 5, subtract 5, 15, right, to get to term 15. I can just plug 15 into this formula. So I'm taking my first term of 4 and I'm subtracting 5 14 times to get to the 15th term, right? So plug in 15 and see what you would get on your calculator. You're doing 4 minus 5. And then if you want to do the parentheses, you can, but you should know that 15 minus 1 is 14. So you'd be at what? Negative 66. So you're using your closed formula just like a function. Plug in any x value that you want. I can only plug in positive integer n values. And it just says, why would using the closed formula be more efficient than the recursive formula? Because recursive, you must find all 14 terms before it. Right? Closed formula, you could plug it in and bam, you've got your answer. So you always want closed. We're going to look at recursive because they're like Fibonacci, there's a couple times when you might only be able to represent it with a recursive function. And I want you to be able to read recursive functions. So the recursive formula is very similar in format. Recursive, I just like to use a sub k to remind myself that it's recursive and not closed, but you could also write a sub n. What do? I take the term that comes before it, a sub k minus 1, and do what? Subtract 5. So how do you get the term you want? You take the term that comes before it and subtract 5, and you have to tell the person that a sub 1 is equal to 4. So I kind of squeezed it in here, but that is my recursive formula. It looks slightly similar. They both show you the common difference, but this allows for direct substitution, and this you'd have to develop all of your terms. All right, so let's do example 2 together, and then maybe you can try example 3. It says find the common difference and find the closed formula, and then use it to find term 8. So what's my common difference? The difference is what? What are you adding each time? Positive 4, right? So I'm adding a difference of 4. So how do I write the closed formula? A sub n equals, you write down your starting term, which is 7, and then you write plus your common difference, parentheses, n minus 1 times. And you don't have to say what the starting term is because this is not recursive. So now you're going to plug in 8. So you're taking 7 and you're going to add 4 7 times. So a sub 8 would equal what? You're taking 7 and you're adding 4 7 more times. So you get 35? All right, so you do example 3. See if you can write the formula for yourself, find the common difference, generate the 8th term. And there's some practice on the back that will allow you to kind of practice this skill too. And we just need to know this formula. You can't do a series if you can't write the formula yourself. So very similar to a linear function. It's just a slope and a y-intercept. It's just written a little bit differently. All right, so what if they give you only some of the information? On this one, they want you to find a closed formula, but they're giving you the 4th term and they're giving you the 13th term. So what I do is I just kind of write out, okay, the 4th term is 20, and then the 13th term is 65. How many terms have passed to go from the 4th up to the 13th? How many terms did I have in between? 9, right? So I had 9 terms. And how much did I add to my original number to go from 20 up to 65? Did I add a number or subtract a number? I added what? 45 was my total sum that I added. Okay, so if I added 45 and there's a common difference over each term, what did I have to add every single time? So you would take your total and divide by your number of terms. 45 divided by 9 is 5. So I just found my common difference. So I know that my common difference for this problem is 5. I need to use that to write my closed formula.
So you can either go backwards in your head or go backwards, with just pattern, right? The third term, the second term, and the first term would be 15, 10, and 5. So now I know the starting term is 5 and the common difference is 5. So there's two ways you could write this sequence. Let's first write it the way that we've been practicing, right? My starting term is 5, and I'm adding 5 n minus 1 times. But these are really just the factors of 5, right? 5 times 1, 5 times 2, 5 times 3, 5 times 4. So your shortcut formula could just be 5n. If your starting term and your common difference are the same number, you don't have to write it out this way. You could just write 5 times n. But if you like consistency, you're more than welcome to use that same formula every time. I just think it's easier if it's just 5n and you know that you're looking for the 20th term, now you just have to do 5 times 20, right, in your head is 100. I don't have any room, but a sub 20 would be 100. And you'd get the same thing here because you'd start at 5 and you'd add 5 19 times. So that is also 100. All right, let's do another one. Find a recursive formula this time. They're giving you the second term is 8 and the 12th term is 28. So how many terms did you go up and how much did you add total? So we added a total of 20 and then there were 10 terms. So what does my common difference have to be? 20 divided by 10, my common difference is 2. I have to write a recursive formula and list the first through the 5th term. I know the second term is 8. So what did the first term have to be? Common difference is 2. So this had to be 6 to add 2 and get to 8, right? So then I would add 2, 10, add 2, 12, add 2, 14. So see if you can write out a recursive formula for this one. You can look up at the top for the general formula. And then once you've written your formula for number 5, I'll put it up in a minute, but see if you can problem solve number 6. Would 82 be in that sequence? Yes or no? And which term would it be? See how you would problem solve that one. There's some critical thinking here on this Friday before vacation. So see if you can problem solve number 6. Just take a minute and think about it. How could you figure out if it's in the pattern, and can you figure out what term it is, either by guess and check or writing a closed formula for yourself? So you actually went for writing out that formula. You said it was 6 plus 4 times n minus 1, and then did you guess and check, or how? So you plugged this into the y equals menu and then skimmed down. That's a good strategy. Did you have a different strategy? That's a good strategy. So he was thinking multiples of 4, if you had started at 4, right, would have landed at 80, and we're starting at 6, so we're landing at 82. Okay, and then what did you do? Okay, if you write the formula 6 plus 4 times n minus 1, you know that has to be the formula, and if you set it equal to 82, that's how you could solve for n by hand. So you're subtracting 6 to the other side, right? Subtract 6. So now I'm at 4 times n minus 1 equals 70. What would that be? 76. Then divide by 4. You did this? So 76 divided by 4 has to come out to an integer or it doesn't work. So n minus 1 is 19, add 1, n is 20. So yeah, so there's many ways that you could figure it out. Guess and check, use a table, use a formula, but yeah, so you could problem solve. If it doesn't come out to an integer, it does not fall in the pattern because n can only be a positive integer, right? All right, so think you got it? Oh, there's a couple applications at the bottom, but they're really just patterns of arithmetic a sequence. So I think you can do them, but if you need help on the applications, let me know. But they're really just kind of exactly what we did on the front page, finding a closed formula, generating terms of a sequence. So I think you should be okay. We'll go over it in about 10 minutes. The answers, then I'm going to unpause it here. Here are the answers to the guided practice, so you can check your answers.